team, it's Mr. Z, and today we're going to review some questions and answers you might have about the study guide. Let's go ahead and dive on in. So just so you know, these blue links are videos that you can click. I'm going to go through a smidgen of problems in this series. All right, here is an area of a shaded region. Number 1 and number 2 are essentially the same type of problem. Now, what you're going to have to do is just remember that the solution is always going to be equal to the area of the shaded. Let me zoom in. Is going to be equal to the area of the total minus the area of the parts. So the area of the shaded region is the total, and we're going to take away the parts that we do not want in our calculation. So farmer is fencing in his rectangular field. This word rectangular implies that I'm going to use the area formula for a rectangle is equal to the length times the width. All right, each fenced-in portion has a width of 10 feet as shown below. So each fenced-in portion has 10 feet. All of these regions are going to be 10 feet. Now, I do know a couple more things about this diagram, and it's because these are rectangular plots. Rectangles have opposite sides that are congruent. So this is going to be 2x, here is going to be 2x, so on and so forth. All of these rectangle side lengths are going to be 2x, and you can see how it causes a chain reaction, so I know all of the widths. Now, what is the height? Well, 10. So the area of the shaded region is going to be essentially, or the width of the shaded region. The width is going to be this guy. I can also check here in my word problem. So I'm going to go ahead and take the total, which is 8x. And what I'm going to have to do is subtract the unshaded regions, the parts. So it's going to be here. These regions are going to be each 10. So it's going to be minus 10, minus 10, minus 10, and minus 10. This is going to leave me with the width of the shaded region. I could clean this up to a high quality answer, producing 8x minus 40. For B, I have to define the function a of x for the area of the shaded region. So what I'm going to do here is first name my function. It's given. They want the answer in the form of a of x, which makes sense because it's area. And the shaded region is going to be the width times the height. So what I need to multiply here is the width, which I calculated. It is not going to be 8x. It is going to be 8x minus 40 times the height, 2x. And this is going to go ahead and give me the area of the shaded regions. Okay, I can go ahead and clean this up. The a of x is going to be equal to 16x squared minus 80x. What is the maximum area that the shaded region can be if the width is 200 feet? Well, the width was given to me in part A. Well, the width is equal to 8x minus 40. So if the width is 200, well, okay, I go into my equation solving abilities, and I get 240 is equal to 8x, leaving me to understand that x is equal to a value of 30. So I need to find the maximum area. Well, my area is a function where I need to put x in. Well, I just found this x value, so I'm going to substitute it in. All right, the output is going to result in the maximum. And then go ahead and finish it for yourself. Okay, number 2 is going to be the same idea, except for minusing 4 parts. It's going to be minusing 2 parts. All right, number 3. Consider this function x minus 2, x plus 5, and dilate f of x by 2, x, to create a new function of a higher degree. Okay, so dilate means to multiply. So my new function is going to be h of x is equal to my old function being multiplied by 2x. This will cause it to be a degree 3. Notice the zeros. Since there are 3 x's, there are going to be 3 zeros. They're easy to identify. 2, -5. Hey, what number multiplies by 2 is equal to 0? 0. If it helps, think of this in a parenthesis as well. There are 3 groups. There are 3 zeros. When x is equal to 0, 2, and -5. If I ask for it in an x-intercept form, remember, these are zeros. Okay, team? Well, this is going to be a positive number, comma 0. Here, this is a negative number, comma 0. All of these y values are 0. So if I needed to give it as a coordinate, it would be like so. Number 4, analyze the graphs of f of x and g of x, the blue one and the red one. And basically, we need to multiply. So this idea is that you just have to analyze the outputs. If something is below the x-axis, here's the y in the middle. But if it's below here, it's a negative. Over here, it's positive. And at the origin, it's neither. Notice the origin is on the x-intercept, which is a 0, which means it's not going to have a charge. It's not positive or negative. It's 0. So in order to sketch this without technology, because I didn't give you the equation, is that you're going to just look at the zeros of the graph. G of x has an x-intercept that's some negative number. F of x, it's going to have an x-intercept right here. Okay. What I'm going to have to do now is multiply and look at the behavior of the graph. So essentially what I'm going to do is the red line over here before it is a negative. Right? It's below the x-axis. Here, it's a positive. So this region, it's going to be a negative number. If I look at the region between the zeros, notice how they're both positive. So it's going to be a positive times a positive, resulting in a positive part. Over here, it is going to be a positive times a positive. So it's going to be positive over here. So you can get the idea that it's going to go from a negative number up to a 0. It's going to go positive. Going to go back to 0, and it's going to go positive again. The same idea with number 5. You look at the x-intercepts. All right, let's look at the spaces in between. Notice how both lines are negative. This is positive, this is negative. A positive times a negative is going to be a negative. Here, they're both positive. A positive times a positive is going to be positive. And then here, it's a positive times a negative, so it's going to be negative. So it's going to go negative, positive, negative. So it's going to essentially look like this. Bada bing, bada boom. All right, number 6 is basically saying, consider these expressions, group 1, group 2, and group 3. Write new functions m of x as the product of the 3 given expressions. Write the function m of x in standard form. So product means multiply. We're supposed to know that. That's supposed to be common knowledge. So I'm going to multiply this group times this group times this group. They're all going to be in parentheses. And what it wants you to do in standard form, well, standard form is when it's going to be looking like, well, m of x is equal to a times x squared plus bx plus c. So the idea is, okay, it's called m of x, and I have to multiply all of these terms together. So basically, it's a matter of distributing and being a bomb. So basically, you can distribute a couple of things. I'm going to actually distribute these guys first, is going to be the idea, because I want to do the more complicated thing first in order to prevent errors in the future. So I'm going to go ahead and multiply this out, negative 8x squared, then it's going to be negative 12x minus 2x minus 3. Okay, before I multiply, I want to clean it up, so I have to do as least work as possible. Okay, now when I'm going to multiply, I have to multiply the x. So I'm going to distribute the x to everything first. Just raising everything to the next power. Now I'm going to multiply everything by positive 2. And then finally clean it up as requested. Okay, so you might be asking me, Mr. Z, notice how there's x to the 3. It's in front. It's going descending order. This is the standard form of quadratics. Notice how our function m of x is not a quadratic. It's degree 3. A quadratic is only degree 2. But this is good enough. Number 8, writing a number of a cubic function with 3 distinct roots. Distinct is going to be another word. It's different, distinct, different, distinct, different. So I'm going to create a function, f of x, and I need to have 3 different roots. So x plus 1 times x plus 2 and x plus 3. The roots are, what number makes a 0? Negative 1, negative 2, negative 3. Just make sure each group has a different answer. Number 9 is kind of the opposite. It needs to be a cubic function, so it's going to need 3 answers, and it has 1 root with a multiplicity of 3. So the same guy is going to be f of x is equal to x plus 1 times x plus 1 times x plus 1. 3 roots, but the multiplicity of 3 means that it's being repeated. Okay, this is the fundamental theory of algebra. Basically, it's all about the x-intercept. So when you multiply groups together, the x-intercepts stay. When you go up to above, when we're multiplying the 2 lines together, we always looked at the x-intercepts. Notice, always, always, always. Notice there's how many roots? How many roots? How many roots? So, in 10, basically, there are 4 roots. Notice, though, there is not 4 groups. F of x is degree 3, not degree 4. Meaning it does not match. The equation and graph. Here, now this negative 2 is okay because look, x times x is going to be x squared, a degree 2. Now, I am going to go ahead and look at this further. On the surface, this looks like a yes, but I want to also look at the roots. It's in factored form, so this lets me know that the roots are, what number makes x minus 1 0? It's going to be 1, 0. My other root is going to be negative 4, comma 0. Is this believable? Yes. So notice I checked a degree 2, and the roots are in the possible spots. There's a negative and a positive one. So yeah, g of x is a possibility because it is degree 2 and the roots are in the appropriate places. All right, try it on your own for the next one. 13, 14, 15 is the unit 1 stuff. This is where it's going to come back. Basically, you have to look at an equation and tell me, is it concave up or concave down? I see that this is a positive 2, which means it's going to be concave up. I have to ask myself the x-intercepts. What makes these 0? Well, that's 3. That's negative 4. Okay. X-intercepts are always going to be when the y value is 0. So to put this in an intercept, it's 3, comma 0, negative 4, comma 0. Number 14, it is a negative 1 in front. A is negative 1, meaning it's going to be concave down. My vertex is always going to be the h value k, hk, compare it with the form. And then this, the axis of symmetry, is always going to be equal to the x value. X is going to be 3. The x value is 3. Last one, concavity. A is positive 2, meaning that this is going to be concave up. And then the y-intercept is the number. I have to just look at it. Well, the y-intercept, notice, it's going to either be a negative number in the y value or a positive number in the y value. The x values are 0, so it's going to be 0, comma 1. These are the tricks I do to make sure I put the 0 in the right spot. Continuing our adventure, number 16, to solve it, you just have to ask yourself, hey, what makes a 0? What makes a 0? Here, it's 7. X is 7. If you want to write it out formally, you can do x minus 3 equals 0 and add 3 to both sides to get x equals 3. It might help you to do that because when 2x plus 5, you might not be able to guess whether it's equal to 0. But using integer of operations, you can realize that 2x is equal to negative 5. I divide both by 2, and I get x is equal to negative 5 halves. So my solutions are negative 5 halves, 3, and 0. It makes sense. I have 3 answers because this function is degree 3. Number 17, what I'm going to have to do is just take the square root of both sides. The square root of that and the square root of that is going to be x is equal to positive or negative 4. And this is because a 4 times a 4 is 16, and a negative 4 times a negative 4 is still a positive 16. Notice it's 2 answers because it's degree 2. Number 18, this is the same thing as number 19. Basically, in order to solve, you need to get into standard form. So I am going to go ahead and subtract 3 from both sides before I even get started, because this is going to help phrase the problem in a way where I can factor it. Okay, 0, product, property. I already subtracted 3 to make it equal to 0. I have to rewrite it as a product. That means I need to factor it. So my favorite method on the planet is this area model. I'm going to put the first and the last term in the box, 2x squared and negative 3. What numbers multiply to be negative 3? I see that it's a negative 5, so I'm going to make sure I keep the 3 as a negative because it's the larger digit. And now I'm going to go ahead and make the 2 and the 1. 2 times 1 is 2. X times x is x squared. This has a specific combination because it's going to give me 2x squared minus 6x plus 1x minus 3. and I can get to the finish line seeing, yes, this is the factored version. 2x plus 1 times 1x minus 3 equals 0. At this point, team, write it out if you need to. 1x minus 3, you can write it out. It is x is positive 3. Notice, just kind of ask yourself, what would make that group 0? 2x plus 1, though, some of you have problems with fractions. So, all right, let me go ahead and just go through the process. It only takes a moment. X is going to be equal to negative 1/2. Notice I have two solutions, degree 2. Okay, team. So these are the same type of problems. The last thing on the menu is just to make sure you guys can evaluate a function. And I'm going to do one of the more complex ones where basically you have to evaluate two functions and then do something with the answer. Here in 25, it wants you to take the answer of m of 2 and multiply it by the answer of p of negative 3. So the first thing I'm going to do is put this 2 into this m of x. So m of 2 is going to be equal to negative 2 squared minus 5. Let me go ahead and figure out the answer. Negative 2 times negative 2 is a positive 4 minus 5. This is going to result in an output that is negative 1. I'm going to do the same thing here. P of negative 3. P of negative 3, and plug it in here. P of negative 3 is going to be equal to 2 times negative 4 times negative 3 plus 3, all in an absolute value. Now I have to evaluate the inside first. Negative 4 times negative 3 is going to be positive 12 plus 3. Continuing to evaluate the inside, I have to take 2 absolute value of 15. This is going to be 2 times the positive version of 15, which is going to be 30. I take my answers and I have to multiply them together. So it's going to be negative 30. All right, so make sure you do the study guide, watch the videos, click on these links, and do everything you can before the test. Good luck, team.